Imagine this. A robot takes a step forward, hesitates, then adjusts its balance like a child learning to walk. But it isn't being remotely controlled. It's actually thinking. Welcome to a new era, where AI is no longer trapped inside screens or servers. It's stepping into the physical world. Over the last few years, AI has been disembodied pure software. It could chat, write, or analyze, but it had no sense of motion, no touch, no gravity to obey. That's now changing. Companies like Figure, Tesla, and Sanctuary AI are building humanoid robots powered by the same kind of neural networks that drive today's large language models. Except these don't just talk, they move, they lift, they learn by doing. The idea is simple, but revolutionary. Once AI interacts with the real world, it can teach itself faster than any human engineer could program it. Think of how a child learns. They don't memorize physics equations, they push, fall, and adapt. That's what embodied AI is doing now, learning through experience. In training labs, these humanoids walk endless virtual miles in simulation before they ever touch a real floor. Each failure becomes a lesson. Each stumble improves the algorithm. We've taught computers how to think. Now, we're teaching them how to live in our world. And look, this isn't about creating science fiction characters, it's about practicality. A humanoid form can handle human tools, navigate human spaces, and work human jobs. No redesign of factories or cities required. But to truly understand why this matters, we need to look inside their digital minds, where language meets motion. And the line between reasoning and reflex begins to blur. Inside a robot's brain, movement is math. Every step is 1,000 calculations per second. Yet what's driving this is not hand-coded engineering anymore. It's machine learning. These robots don't follow fixed instructions. They evolve behaviors. In simulation environments, vast digital playgrounds like Isaac, Jim, or Mujoko, they experience millions of lifetimes of trial and error in just a matter of a few hours. Reinforcement learning rewards them for success like standing upright or opening a door, and punishes mistakes. It's a feedback loop between mind and body. The more they move, the smarter they get. And now, large language models, like the same kind of intelligence behind ChatGPT, are entering the mix. Imagine saying, "Pick up that tool and tighten the bolt," and the robot understands not only the words, but the context, the sequence, and the physics required. This is the merger of symbolic reasoning and embodied experience, the cognitive and the physical fusing into one system. Engineers call it embodied cognition, intelligence shaped by the body it inhabits. For AI, that means thought and movement evolve together. A robot that can reason and reach. That's the real leap forward. It's like watching the Industrial Revolution meet the information age in one machine. The steel of the factory merges with the silicon of the server. But there's a catch. The moment machines can act autonomously in the real world, every mistake has real consequences. A misaligned hand could break glass. A misread command could cost lives. That's why safety, alignment, and ethical control are now as critical as speed or performance. The question isn't just how they'll move, it's who decides where they go. In labs around the world, humanoid robots are already stacking boxes, tending machines, and in some cases, teaching each other. Yes, teaching. Shared learning networks allow one robot's experience to instantly update the others. A lesson learned in one warehouse becomes a global update, a kind of collective muscle memory. This is fleet learning, and it's how embodied AI will scale exponentially faster than humans ever could. Once a robot understands how to fold a shirt or fix a valve, every identical model can do it. The learning curve collapses. The physical world becomes programmable. But here's the paradox. As we give AI bodies, we also give it limitations. Weight, friction, fatigue, spatial constraints, the very challenges that shaped us as humans. And maybe, in that struggle, machines will gain something we lost: patience, persistence, and curiosity. The first industrial robots replaced muscle. The next generation replaces mind. These new ones? They might replicate the full human loop: perception, motion, intent, and adaptation. Soon, humanoids could become the interface between the digital and physical worlds, the hands of the internet and the brains of the algorithmic economy. So, when we see a robot take its first cautious step, maybe we're not watching the rise of machines, but the next chapter of evolution itself. Welcome to the age of embodied intelligence. Behind every humanoid robot that walks across a lab floor, there's a much bigger story unfolding. A race. From Tesla and Figure AI in the United States to 1X Technologies in Norway and Agility Robotics in Oregon. The world's richest companies are quietly competing to solve the final piece of automation, giving AI a physical form. Why humanoids? Because they fit. Every factory, warehouse, and workspace on Earth is already designed for the human body. The height of a shelf, the width of a door, the grip of a tool. A robot shaped like us doesn't need a new world to operate in. It inherits ours. That's why investors are calling this the iPhone moment for robotics. Once someone perfects the first mass-producible humanoid, the entire world's labor system could change overnight. Today, one of these machines costs more than a luxury car, but their cost is falling faster than anyone expected. As production scales, analysts project the equivalent cost of $20 per hour by the end of the decade. Think about that. A tireless, programmable, adaptable worker at the same cost as a human shift. For aging economies with shrinking workforces, that's not science fiction, it's survival. Japan, Germany, and many Western countries, they all see humanoids as the next industrial backbone. And for companies like Tesla, the opportunity is even larger. If they can build reliable synthetic workers, they don't just sell cars, they sell labor itself. In the 20th century, we automated production. In the 21st, we're automating people. The question now isn't if these robots will join the workforce, it's who will own the future when they do. Because whoever wins this race won't just control the next trillion-dollar industry. They'll control the hands and the reach of artificial intelligence itself.
Follow Axicode for more.